Now, a lot of this stuff is old stuff you've done in grade 8 and grade 9, so just bear with me. First of all, where do we get our energy from? Okay? What are our sources of energy? What are our sources? Where do we get them from? The sun is the source of energy. Wind is the source of energy. Flowing water is a source of energy. All right. In general, people, this is nothing new. We can put fuels, our energy sources, into two basic categories. The one considered to be renewable, the other one non-renewable. The non-renewable sources, people, you should know at this point, we use them up faster than what the processes can produce them. Okay. Renewable sources are sources that can be replenished or replaced in a moderate period of time in general within our lifetime. Okay, sometimes shorter, sometimes every 3 months or 6 months it can be replaced. The renewable sources, solar energy, water energy, wind energy, wood, burning of wood, geothermal, and tidal. Now the ones we use in Namibia, sun and water. In general, in Namibia, we use a lot of sun for heating water in a solar geyser. Okay, many houses have a solar geyser. And then lots of places have put up solar panels. When you drive around in Windhoek, you can see the solar panels on the roof. Yeah? Replenished is replaced. Okay? If you replenish your energy supplies, you eat a bar of chocolate and you drink a tin of Coke and you have a hamburger. Okay? Then you've replenished your body's energy supplies. All right. So the renewable sources can be replenished, can be replaced in our lifetime or in a short period of time. Non-renewable can't. People, where in Namibia do we use water energy? Yes, Ruakana, the hydroelectric power station, generates electricity from water that falls down a waterfall driving a turbine. Yes. We use a little bit of wind in the form of wind pumps, but we don't generate electricity on a large scale in Namibia with wind generators. Maybe in Ludwitz one could put up a wind power station because there's lots of wind. But here in Otjiwarongo, do we have a lot of wind? No. Geothermal, we have a little bit of hot water springs near Grasbalmen, but we don't really use it on a large scale to generate electricity. There are some places where they use the steam that shoots up from the cracks in the earth to drive turbines to generate electricity. They build communal kitchens over these sources, and they use the steam to cook food with. All right, Hawaiian Islands. Okay, so it can be used. Tidal energy, we don't use it around here. I think some of the European countries along the coast, they might use a bit of tidal energy. They've got large buoys in the ocean that lifts up and down together with the movement of the waves. Or they build dams. When it's high water, the water flows into the dam. And then there's an opening with a propeller that drives a turbine. When the tide goes down, the water runs out of this dam and it drives a turbine, generating electricity. So as the tide comes in, turns in the one way, tide goes out, goes in the other way, generates electricity. There's continuous movement. All right. Although I think it's more difficult to harness tidal energy than any of the others. Okay. The non-renewable sources, people in general, the fossil fuels are non-renewable. Coal, oil, natural gas. People, even uranium, even though we only use a very tiny amount of uranium in a nuclear power reactor, the uranium supplies are not infinite. All right. So it is actually not so very renewable. Some sources classify it as renewable, but you can argue it a bit both ways. Now, the next one. When we're going to have a look at the renewable and the non-renewable sources, The renewable sources, what are the advantages? Well, they will never be used up. We will always have some form of energy. There will always be wind. Say again? Okay. There will always be wind. There will always be, well, water flowing in rivers. There will always be wave motion because of the attraction of the moon, the gravitational fields, etc. These sources usually have no pollution in the form of greenhouse gases, mainly carbon dioxide. All right? The maintenance, they say, is not too expensive, but that is also relative. But okay, it's not impossible to do. If we go and have a look at the disadvantages of the renewable sources, then we will see the renewable energy is spread over large areas. For example, if I want to have a solar plant with solar panels, I need a very large surface area on which I could put the panels. If I go outside here in the cities, how do they solve that problem? They put the panels on the roofs of the buildings. All right. But we still require a fairly large surface area to generate a little bit of solar energy. The technology to harness the energy is not fully developed. People, I think, if we go and look at solar panels and their costs and their efficiency, in terms of the last 10 years, the new solar panels can do much more than what the initial ones could do. All right, they can generate greater amounts of electricity. Yes. The sources are not always available. I think 50 years ago in Namibia, I don't know if there were many solar panels, and I think Europe already had solar panels. Okay. It takes some time for things to become available. There must be a demand, and it is a process. So sometimes it's not always available. And then lastly, even though there's no pollution, there is always some environmental consequence. For example, at Ruakana, if they dam up the water at the top of the waterfall, the part of the river below the waterfall is either going to have less water, or it's going to have more water if they let the water out than what it should have if it was just naturally constantly flowing. So there's always a little bit of ecological damage, but the environment tends to adapt to that better than it does to normal pollution. All right. The fossil fuels, non-renewable sources, what are their advantages? Well, they are fairly concentrated sources, and they can release a fairly large amount of energy for a small amount of fuel. I can fill up my car's petrol tank, and I can drive around for a month, if I don't drive too much, maybe a little bit longer than a month in town. All right. Developed simple technology to harness these sources. Very basically, most of these sources have to be burnt, and from that the heat is used to generate electricity, and from that we can convert it to whatever we want with the apparatus that we plug in. The disadvantages of the non-renewable sources, eventually it will be used up. So we are going to reach a point, if we are completely dependent on these sources, we are going to reach a point where there isn't any more. I don't know if you've ever been hungry and gone to a cupboard and opened it up and there's nothing in the cupboard. That's what it's going to come down to. So it's very wise to start looking at alternative sources. And that is why in Namibia, on a fairly large scale, we do use solar panels. And I think in the future, it's going to even become more. Okay. And generally, it causes pollution because most of them have to be burnt. And when we burn hydrocarbon fuels, we get carbon dioxide and water vapor. And together these form the so-called greenhouse gases. Different sources of energy. We can use chemical energy. What is chemical energy? Well, it is a store of chemical potential energy. Where is the energy stored? Within the chemical bonds, in other words, in the covalent bonds when electrons are shared. Within the ionic bonds, when opposite charges attract. Okay? That is where the energy lies. So we often have to burn them to release the energy, and any hydrocarbon fuel, when I burn it, it will form carbon dioxide, water, and energy. If there isn't enough oxygen, if there's incomplete combustion, I can get carbon monoxide and carbon forming. All right. Yeah. If you drive around with your car in Windhoek long enough, and at a certain stage, if you pull your finger along the car, then you'll see it's like a blackish, grayish layer on the car. That is from the carbon, among other things, due to incomplete combustion of all the car engines. Potential energy from water. Water is dammed up at Ruakana on the higher part of the river, and then there's a waterfall. It is released. The gravitational potential energy of the water as it falls is converted to kinetic, and then this is used to drive a turbine, and we generate electricity. We can use movement from tides, and this can also then be converted to electrical energy. Geothermal, we don't use much of that around here in Namibia. Grosbarman, they've built the hot water springs, and at ice, where they use it as a resort for people to go and swim in the hot water. Okay? How does it work? We know that the core of the earth is molten, so it's very hot, and there are cracks in the surface of the earth, and the water goes down these cracks, and it heats the water, and it becomes steam. The steam is forced up through these cracks, and if they build turbines in specific places, it can drive a turbine, which can be used to generate electricity. All right. Hot water from the springs can be used to heat nearby buildings. All right, by piping it through a system of radiators. Water has a very large specific heat capacity. So it can take up a large amount of energy with every 1 degree change in temperature. But then similarly, when water cools down, for every 1 degree drop in temperature, for every 1 kilogram, it gives off 4,200 joules of energy. And that is why water is very useful in a radiator system for heating or for cooling, as in cars. Okay, nuclear energy. We had a look at some of the nuclear reactions just previously. We said we get what is known as the chain reaction. Remember, I said we need a uranium bundle of nuclei. We shoot a neutron into it. It becomes unstable. It splits, and it shoots out 3 other neutrons, which can go smashing into a uranium nucleus, causing them to split. All right. Now, when we talk about nuclear energy, we can work with 2 types of reactions. I said to you the fission, which is splitting, and fusion, which is adding together. If something fuses, it becomes one. All right. So by adding nuclei together or by splitting a nucleus. Now, usually fission, we use large nuclei. Now, if you look on the periodic table, would I be able to split a hydrogen nucleus? Why not? It only has 1 proton. Would I be able to split a helium nucleus? Well, technically speaking, it's not impossible, but imagine having to hit a particle containing a proton or 2 protons and 2 neutrons, trying to get a neutron to smash into that. It would be like trying to hit a coke tin on a 2-kilometer distance with a gun. It's almost impossible. So, the type of nuclei that is used to split is the bigger ones. Uranium, okay, is relatively speaking a large particle. So, large, unstable nucleus splits into 2 on impact with another particle. This other particle is very often a neutron that is shot into it. It releases a very large amount of energy, which can be calculated with E equals mc squared, because there's a discrepancy in the mass. Okay. When these unstable nuclei do not produce enough energy, they are left as nuclear waste, which is still radioactive and therefore harmful to the environment. I say to you people, this nuclear waste remains, well, radioactive for very often millions of years. Yes. The fusion reaction occurs on the surface of the sun. And what happens is two hydrogen nuclei collide. They smash into each other. And if they smash with enough energy, they fuse. And element number 2 that contains 2 protons is helium. And that is where the helium on the sun comes from the fusion of hydrogen. It forms helium and very large amounts of energy. That is the energy from the sun. Yes? Yes, they reckon, I think if I remember correctly, that like up until now, about 4% of the hydrogen has been used. It's not something we have to worry about. Okay. Yeah. All right. Solar energy is produced by nuclear fusion. Solar energy, sunlight. The energy from the sun, hydrogen and hydrogen that fuses. So solar energy is as a result of nuclear fusion. Hydrogen nuclei join together, it forms helium. There's a mass discrepancy between the two particles if you add them separately, and when they've fused, this difference in mass, if you put it into the equation, it gives you a value of energy. All right, because this C squared is 3 times 10 to the power 8 raised to the power 2, so it is actually 9 times 10 to the power 16. So it's 9 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. If you multiply any number with that, you still have a very large amount. You understand? Okay. So solar energy can be used for heating, for photosynthesis, and to generate electricity with so-called photovoltaic cells. When we add lots of photovoltaic cells together, we get what is known as a solar panel. We will stop there.
Dear teachers, we know all the hard work you put in every day to make sure our kids get the best education possible. It's also our goal here at One Africa TV's #LearnOn1. That's why we bring free quality supplementary lessons that are 100% Namibian, complements of NMH's MyZone. Lessons include early childhood development programs and primary school lessons. These air on One Africa TV every weekday from 9 to 11 a.m. with repeats from 2 to 4 p.m. There's so much to learn with #LearnOn1. Invite learning in.
We were busy with the sources of energy. We have to carry on. More or less in the textbooks, they're on page 194, 195. I will carry on here with the notes. So, we said the last period that chemical energy is stored where? Within the chemical bonds. In other words, if it's a covalent bond, between the shared electrons is where the energy lies. In the ionic bond, the attractive force between the ions that hold the particles together, between those particles we get that the chemical energy then is stored. So just simply a fuel is a store of chemical potential energy. All right? The energy is stored within the chemical bonds. And very often the fuels that we use, they will release their energy when we allow them to burn. In general, any hydrocarbon fuel. Now, examples of hydrocarbon fuels are wood, coal, petrol, diesel, paraffin. The gel that you buy, that green gel, is also a hydrocarbon fuel. When they burn, they react with oxygen, they form carbon dioxide, water vapor, and energy. We know a little bit about the energy from water. Ruakana, the water is dammed up on the higher part of the river, and the power station is built below, near the bottom of the waterfall, and the water falls down onto a turbine. It drives the turbine, the movement of the water, which drives a generator, which generates electricity. We can also use the movement of water from tides. There are various ways of doing it. Sometimes with a high tide, they dam the water up in like a pool, and then when the tide goes out, there's a hole in the wall of the pool with a propeller which drives a turbine which generates electricity, etc. Okay. Geothermal energy, we don't have many sources here. Grossbarmen and ice are hot water supplies or sources for us, geothermal. The water is heated from the hot core of the earth. All right, there are some places where there are cracks in the earth and there's water that is available, and the water goes down these cracks and it goes very close to the core of the earth, becomes hot, it boils, and it shoots up as steam. Okay, that is geothermal energy, and that steam then can be used to drive a turbine to generate electricity, or it can be used directly to heat buildings or to cook food. Nuclear energy, we've already had a look at that. Fission and fusion, two ways in which we can harness nuclear energy: by making two nuclei fuse together like the surface of the sun. Hydrogen and hydrogen collide, they form helium, and it gives off large amounts of energy. Fission, we said, large nuclei like uranium are split. Okay, don't want to say much more about that. We've done that. Just fission and fusion. Fusion, they fuse together. Fission, we split the nucleus. Solar energy on the sun is nuclear fusion, where hydrogen fuses with hydrogen. We've already said that. The energy, there's a mass discrepancy before the fusion and after the fusion, and that mass discrepancy is multiplied by the square of the speed of light. And I said to you, the speed of light is 3 times 10 to the power 8, so the square is 9 times 10 to the power 16. I think if you multiply anything with 9 times 10 to the power 16, you get a very large number. Okay, so that is where the energy of a nuclear reaction lies in. Solar energy, we can use it directly for heating. Many of our houses have solar geysers. It's a panel connected to the geyser through which there are different ways the water is heated by the heat from the sun through the panel, okay, stored in the geyser. Plants photosynthesize. You've done this grade 7, 8, 9, all right, 10. What do plants do? They carbon dioxide, water vapor, in the presence of chlorophyll, and they need sunlight. In other words, photosynthesis is endothermic. All right, they release sugars and oxygen. Solar energy can also be used to generate electricity. I think in Namibia that is very widely used. We have solar panels, it's a specially made solar panel that converts sunlight into electrical energy with the use of something known as a photovoltaic cell. And a little bit later on we will have a look at how they work. All right. A group of photovoltaic cells is called a solar panel. I think these things are put together, the photovoltaic cells are put together in a solar panel so that one solar panel can supply so much. All right, and then they use that to work it out. I think it's a standard amount that they put into a solar panel. All right, wind energy, we use that, people, farms to pump water, wind pump. All right, sailboats, wind power generators. More and more when you drive up from Cape Town, not from Cape Town, from South Africa, and you go past Uppington, just before Uppington, on the South African side, not coming from Namibia, there is a wind farm. All right, where they generate electricity with wind-powered mills. All right. The importance of renewable energy. Why is it important? What are we using mainly nowadays? Fossil fuels. Are fossil fuels renewable? No. So why is it important to know something about renewable sources of energy? Well, somewhere along the line, if we keep on using only fossil fuels, it's going to run out. Already, the countries that have oil, they have sort of got the world in an economic grip because they control the price of the oil, and it goes up and down as they see fit. All right, so we should try and find other sources of energy. Renewable sources that we use. We want to reduce our dependency on fossil fuels, and then another one that is fairly important, they talk about a carbon footprint. All right, it's got, among other things, to do with the greenhouse gases that are released, contributing to global warming. All right. Hydroelectric power generation. Yeah, I've just got a very rough scheme of it. What it basically comes down to, water is dammed up on one point. All right, and it's usually in a river, and it's usually at a naturally high point in the river, after which there should be some kind of a waterfall. And then sluices can be opened and closed, depending on what the demand is for electricity. If they open up the sluice, the water simply falls due to gravity down a chute onto a turbine over there. The turbine has propellers, which will be driven around and around by the falling water or the moving water, drives a generator, which generates electricity. Now, when we do this section on electricity, we will have a look at how the generator functions. At this point, it's enough to say the turbine drives the generator, and the moment the generator can move, it will generate electricity, and the electricity is fed into the grid over here via a system of transformers and then to the different cities, but we will have a look at that when we do electricity. Here's a schematic of a wind generator. Now, people, these things are very big. They're very high. The propellers are very large. In general, it seems as if they turn very slowly, okay? But it's because there has to be a certain amount of thrust, and it's actually quite complicated. But very basically, a wind power generator has blades, okay, that catch the wind. They are tilted to a certain angle, and the wind blows against them, and it causes the propellers to turn. The blades drive what is known as a rotor, and the rotor is connected via an axis to a system of gears and eventually a generator. And how do we generate? We need movement. We need something to cause the coil in the generator to turn. Okay, and the moment we have the movement, then the generator can form, it converts the kinetic energy to electrical energy. All right, yes. Wave power generation. Incoming waves cause the water to rise and fall in a chamber. People, they use the natural movement of tides to fill up this chamber. We know that in a 24-hour cycle, there is 2 high tides and 2 low tides. Every 6 hours it changes. And this is the principle on or the basis of the functioning of the power generator. When the water comes up during high tide, the part that has been built closed, all right, dammed up, catches up the water, because the water pushes over this wall over here. And then when the tide goes down, well, below the wall is a turbine. As the water flows out, the turbine turns, and once again, the moment you have movement, we can generate electricity. When we were kids, we had bicycles, and then you had to have a dynamo on your bicycle connected to the light on your bicycle. And the dynamo looked like a little bottle with a head that could turn. And then when you want to ride your bike at night, you push the dynamo onto the wheel, the head of the bottle. So as the wheel turns, it turns the head of the bottle. And that is connected to a tiny little generator. And as you pedal, it puts out electricity, which makes your light burn. And the faster you pedal, the brighter your light burns. And the slower you go, the duller your light burns. Yeah. So when the tide comes in, the dam is filled up. When the tide goes out, it drives the propeller. So when the tide goes out, the water flows through a turbine, produces electricity. Then we get biomass power generators. Now, some of you during a science fair, I think there was one year, somebody with a biomass generator. It's just very simply rotting organic vegetation. When vegetation rots, it forms methane gas. The methane gas can be used to heat water, to create steam, to drive a turbine, to generate electricity, or just very simply, they can burn the organic material. Solar power generators. Namibia has one of the highest solar energy potentials on Earth. These alternative sources very often are limiting in the sense that if it's not available, you can't use it. For example, here in Otjiwarongo, it would be useless us trying to drive everything with wind turbines because we don't have wind every day. If you lived in Ludwitz, wind would be a good option. Okay, because there is wind all the time, blowing in from the sea and then from the land out back to sea, different times of the day. So in Namibia, because we are actually a very sunny country, it's very hot, it's actually quite dry, there isn't very often cloud cover that will shield off the light. Even if there is still enough sunlight to heat geysers and solar panels that can load cells. So in Namibia, solar energy is a very good alternative source. Okay, now we can generate electricity from the sunlight in one of two ways. They talk about photovoltaic cells. We looked at it, or we said that we will look at it a little bit later on. When light shines on them, they contain certain substances, and these substances release electrons. What actually happens is, if you look at a solar panel, you see if you look at the panel, it's dark. Okay? And the material that lies on the panel, the sun reaches the one side, the other side is in darkness. And because of the difference in sunlight, it sets up a potential difference. And this is what makes the current move. Remember, if we have a potential difference, I can push charge from a point of high potential to a point of low potential. All right, so when light shines on some of these substances, they release electrons. We talk about the photoelectric effect. Now, I'm not sure if it's in your syllabus, but photoelectric effect, if you go on to grade 12, you will definitely do it. Okay. We say these substances are photoemissive. Just very simply, some materials, when light shines on them, whether it's from a torchlight or whether it's sunlight or whether it's a specific frequency of light, okay, some materials release electrons. These electrons are referred to as photoelectrons. It's referred to as the photoelectric effect. Okay, and they say then these substances are photoemissive. In other words, they will emit electrons under the influence of light. The word photo tells us light. Photosynthesis, building up with the use of light. Okay, solar cells are made from photoemissive substances like silicon. When sunlight falls on the solar cells, electrons are emitted from the silicon. An external circuit can be attached to the positive and negative sides of the solar cell, and the photoelectrons can then travel through a circuit. All right, people, the positive and the negative side is simply a point of high potential to a point of low potential. The direction of flow will now depend. Solar collectors, sunlight heats up a liquid, which in turn then heats up water. This can create steam, and that steam can drive a turbine connected to a generator. If you go to South Africa and you go over the border, Uppington Way, just after the border, if it's daytime, you will see a bright, shiny thing standing in the distance. That's a solar collector. It's got mirrors, that's why it's so shiny, and it concentrates the sun's rays on a certain point, and this thing then stores heat, and the heat that is stored is used to heat water, which becomes steam, which drives a turbine, which generates electricity. Now, I'm speaking under correction, but I think the one near Uppington works with salt. Salt is a very high heat capacity. So it can absorb lots of heat. It can reach very high temperatures. All right, it only melts at, I think, about 1,500 degrees. So it's really, really hot, yes. Okay, it can absorb lots of energy. And then as the energy stored as heat, it can then be used to boil water, which forms steam, which drives a turbine, which generates electricity. Okay. That is a solar collector. Then, heating, refrigeration, and air conditioning in our country. It's very hot. Most of you people have air conditioners somewhere along the line in your lives. How does an air conditioner work? Well, similar to a fridge. How does a fridge work? Well, what they basically go and do is, a fridge has a compressor, and what it does is it compresses a specific gas that is in the system. When a gas is allowed to expand, it cools. Why? Just in terms of kinetic theory. Yes, it takes up energy. So it removes energy. Particles go from the liquid. They must become a gas. So they take the energy with them, and the gas particles expand. So when gases are allowed to expand, it uses up energy, so it will cause cooling. And then it goes to the compressor, and the compressor compresses it again. Bicycle pump becomes hot. So the compressor of the fridge becomes hot. That is why at the back of the fridge there's a radiator system. If you hold your hand at the back, it's warm. Where does that warmth come from? From the compressor that has compressed the air. It then removes the heat, and in the cooling chamber it allows the gas to expand. And this once again causes cooling because the expansion of gases uses up energy. And once again it goes back to the compressor. All right. Climate control devices, air conditioners and heaters use large amounts of energy. The main source of their energy usage is electricity. New technology is trying to reduce the dependency on electricity. One such method is called absorption refrigeration. This is fairly new technology. They say absorption refrigeration produces cold air from hot fluids by evaporating the fluid. Now people, any liquid, when it evaporates, the liquid that is left behind is colder. Why? Evaporating particles take the energy with them, leaving those behind with less energy. So that would be colder. Alternative method, cooling fluid can be pumped through underground pipes. Temperature underground is cooler and relatively constant. If you dig down maybe 1 meter, the temperature of the soil there is a fairly steady, constant temperature that might fluctuate over a seasonal change from summer to winter with maybe 5 or 6 degrees. But it is, relatively speaking, cool. So what they then can do is the cooling fluid goes to the underground, through underground pipes. Coolant then is circulated through these pipes where it will give off heat. And then the cold fluid is then circulated through the building. Just as they would have in Europe, they use water. In the basements of the buildings, they have a boiler. And it's usually in a closed system. The boiler heats water. The hot water is pumped through the buildings. They've got radiators in the buildings against the walls. I don't know if you've ever seen them in pictures and so on. It looks like a heater, but it's fixed onto the wall, and it works with hot water that comes from the boiler. All right. Now, the cooling system over here works similarly. The coolant is just pumped underground where it will cool off. And then the cold liquid is pumped through the building. So if you have a cold object, it's going to absorb the energy. And because it's being pumped through the system, it will remove it. And once again, taken down underground where it will be dissipated. Water pumping. Farmers dependent on water. All farmers are dependent on water. If you don't have water, you can't farm. No. Okay. Very often the water is pumped up from underground sources. Wind is unpredictable. They do use wind pumps fairly often. All right. The farmers usually know this wind pump will take so long to pump up so many rings on the dam. No. Okay. But if there is no wind, they must go and start the generator. Most of them have a generator somewhere also that pumps up the electrical pump. That pumps up water, yes. All right. Other methods involve electrical pumps, often driven by solar panels or diesel burning pumps. Okay. Okay, how do solar heaters work? Now, your book refers to a specific type. There are various types. This one is called the flat plate collector system. There's another very popular one where they put antifreeze into a system of pipes in the panel, and it's connected via a circular ring into the tank where the water is stored, and the antifreeze is heated by the sunlight, and when it becomes hot, convection current sets up, and this hot coolant or this hot antifreeze is pumped through the tank holding the water, and it releases the heat. Okay, and then it's pumped, it goes out and it goes into the panel again where the sunlight heats it up and it pushes through the geyser. Now this one here works slightly differently, okay? We have a flat plate collector system. They talk about a batch collector and evacuated tube method. Over here at the top is where the hot water is stored. Here is the panel, okay, and this panel contains a system of copper pipes, all right? They say the most common solar heater in Namibia is the flat plate collector system. The flat plate collectors consist of parallel copper tubes fitted to flat absorber plates. It's just a very dark background plate. Okay. The tubes then are connected to each other by two pipes, the inlet and the outlet. All right. Everything is contained in an insulated box covered with glass. The whole system in which this liquid travels is, leak-free, because if it leaks out, then your system is not going to work. Okay. So you use the same coolant or the same liquid in the system of tubes continuously. You would maybe have to fill it up once every 5 years or whatever. Two main methods used to heat the water with solar energy: a direct method and an indirect method. The direct method, very simply, uses the sun. The sun must shine directly onto the panel. Okay. The indirect solar water heats a special fluid with an antifreeze property in the collectors. The heat from this fluid is then transferred to the water and then drains back into the tank. This system is very popular because of the amount of chalk in the water. Kalk in die water. If we heat the water, as a result of the heating process, the calcium hydrogen carbonate changes its form and it becomes calcium carbonate, which is insoluble, and it deposits in the tank and it tends to clog up the tank. Yes. Okay, so then the heat from the fluid is transferred to the water and then it drains back. The water goes into the storage tank, or the coolant drains back into the panel where it is heated by the sun. Convection current set up pushes the liquid through the system and through the water tanks again. They say the system cannot be damaged when the water freezes in the system. Remember, when water freezes, it expands. And this is also a problem with some of the geysers. If the water expands when it freezes, it's going to crack the pipes, burst the pipes. All right. Other solar heaters are based on batch collector method and evacuated tube methods. We just need to know basically one at this point. Batch collectors, they heat water in dark tanks of tubes inside an insulated box. Yeah. the water is stored until it is needed.
Win free airtime with hashtag #LearnOn1. Share your comments on the lessons. SMS your feedback, name and town to 555. Hashtag #LearnOn1. Invite learning in.
Finish up with Unit 12, and it's just the last section that we have to do. It is about the solar heaters. If we go back one little bit, we started off in the previous period when we had class, how do solar heaters work? And there are basically two types, okay? We said the most common one is the flat plate collector system, all right, which is just a system of copper tubes fitted onto an absorber plate. The absorber plate absorbs heat, and then the tubes are connected to each other by two pipes, inlet and an outlet. Everything is contained inside an insulated covered box, a box covered with glass. The glass helps to trap the heat. It's like inside a car with the windows closed. All right, the heat just builds up, it doesn't really escape. Then the direct method uses heat from the sun, and this is more or less where we stopped. Uses the heat from the sun directly. Indirect solar water heaters heat a special fluid, and this fluid moves through a system of pipes into the reservoir where the water is stored, and it gives off the heat to the water, and this heats the water. This system is actually quite good in areas where there's a lot of hard water, because if it was the water circulating through the pipes, they will become blocked with the chalk in the area. No? Okay. Lots of mineral salts dissolved in the water. When you boil the kettle, the chalk that is left in here, our geyser elements, last 2 years, you have to replace them. Here at the hostel constantly. Why? Because of the chalk in the water. Okay, when you heat it, it forms a precipitate and it packs on around the elements. It tends to clog up pipes, etc. So that is why they use this indirect method. Because in the reservoir tank where the water is heated, if there's a bit of chalk, to empty that out is quite easy. You don't have to replace the whole system. Okay, this system can also not be damaged when water freezes. What happens to water when it freezes? It expands, and it tends to burst pipes. All right. Very often in the winter, if the temperature drops very low, below 0 degrees, we often find that water pipes have burst, especially out on the farms where it can get very cold. Other solar heaters are based on the batch collector method and an evacuated tube method. Now, this is just very shortly. Batch collector, it heats the water in dark tanks. Why dark tanks? Dark color helps to absorb heat. Remember, white and shiny substances reflect heat. The black substances absorb it. That's why the inside of a solar oven is also black. The pots that you use is black. No, they line it with shiny tinfoil to reflect the heat onto the black pot. It's not black necessarily on the inside. Okay, so the water then is stored in this container until we need hot water. The evacuated tube system is slightly more complex. We see some of these geysers in town on houses' roofs although they are not as popular as the indirect heating method one. Each evacuated tube is similar to a thermos flask. If you look at this diagram over here, okay, this is an evacuated glass tube like a thermos flask has, all right? They set them up, it's big. It's like a meter long, maybe a little bit more, and it's maybe more than, maybe 1.5 meters long and about a meter wide. Okay, so the radiation absorbing coat, it's just dark, matte, not shiny. Okay, dull paint over the tube. Double-walled evacuated glass tube. Why evacuated? What does that mean? There's a vacuum. No. Why a vacuum? How is heat lost? There are 3 ways in which heat can be lost: conduction, convection, and radiation. And the vacuum prevents radiation from occurring. Okay? Not radiation, sorry. It allows heat in, but it prevents energy escaping by means of conduction. All right. The heat pipe, that will heat the water, and then the heat transfer fluid outlet to the storage tank. Once again, the fluid is heated in this pipe system. It goes into the tank where there will be a spiral through which this hot fluid is pumped, and it warms the water once again. Once again, the water is not heated directly in a system of pipes. The water stays in the tank, and the fluid in the pipes is pumped through the tank to heat the water. All right.
Akiri. Water, water, wash your hands. Scrub with soap, wash your hands. Front and back, wash your hands. To be clean and safe. Wash your hands before you eat your breakfast. Wash your hands before you eat your lunch. Wash your hands before you eat your dinner. Wash your hands before you start to munch. Water, water, wash your hands. Scrub with soap, wash your hands. Front and back, wash your hands to be clean and safe. Wash your hands after using the toilet. Wash your hands after you sneeze or cough. Wash your hands after you touch animals. Wash your hands to wash all the germs off. Water, water, wash your hands. Scrub with soap, wash your hands. Front and back, wash your hands to be clean and safe.
beautiful souls. This is Nikita Winkler, and I am here to share easy tools for stretching that you can do just about anywhere. This is a demonstration, so what's most important is that you take the time in each position that your body needs to release its tension. In this session, we will stretch the hips. What you'll need are yoga blocks or books, thick books, or pillows, especially if you have tight hips. You can do this on a mat, on the floor, on a blanket, or even in your bed. Let's get started. So we're going to start on the floor with the soles of our feet together. I'm going to grab around the feet. This is a butterfly position. So in order to warm up the hips, I'm just going to flap the butterfly wings. And again, take your time. I'm going to lean forward. And here, again, if the hips are too tight, you can place your blocks, books, or pillows underneath. You might even feel a stretch in the back here. From this position, I'm going to take one arm right behind me, not too far from my body. The other arm, inhale, exhale, press the hip open. And come back to center. Change. One arm right behind me to lengthen the spine, the other hand on the knee. Inhale, exhale, press the hip open. And back to center. Now we're going to lie down on the floor. And first, before I get started, I have to make sure that my body, my spine is in alignment. I'm going to just open up the neck area. And you can spend as much time as you need here, allowing the force of gravity to weigh on the legs to open up the hips. You can place your blocks, books, or pillows underneath the knees. And gradually, you can take the feet even further down and spend enough time in each position. From here, we're going to go into an internal hip rotation. I'm going to spread my feet to the side, lean the knees inwards. If you have a little bit more flexibility, you don't really feel the stretch, just take your feet even further apart to deepen this internal rotation stretch in your hips. From here, I'm just going to place my feet, and without repositioning the feet, I'm going to take my arms to the side, and then I'm just going to rock my legs side to side, keeping the upper body facing up, shoulders down. And then I'm going to stop on one side, take the lower leg over the upper to add weight to deepen the stretch. Release the leg and switch. Other side, lower over the upper. And back to center. Last part, I'm going to spread my legs as wide open as I can, and I'm going to just row the boat. So what's important here is that the knees don't lift off the floor. Make sure you row both sides. Keep the knees and both bum cheeks on the floor. Alternatively, you can just lean forward. You can hang out on the pillow. Take your time on the blocks or on your books. And that is it. Thank you for joining me. Don't forget to breathe into your stretches, and happy stretching.